Dear students, today we are discussing about Unit 18, locally compact spaces. Unit 18. Unit 18, locally compact spaces. Compact. Locally compact spaces. Concepts. Definitions. Definitions. The topological spaces X comma tau. The topological space PP means topological. SP means space. X comma tau. X comma tau is said to be locally compact. Is said to be locally compact. Locally compact. CPT means compact. Locally. If each point of X has, if each point of PT means point, each point of X has a, each point of each point of each point of each point of X has a neighborhood. X has a page number 137. Page number 137. X has neighborhood whose closure is compact. NBD. NBD means neighborhood whose closure is compact. Whose closure is compact. CPT means compact. Example. Example. Let X be a infinite set. Infinite set Let X be an infinite set. Equipped with the discrete topology. Equipped means fixing. Equipped, equipped with equipped with discrete topology. Discrete TP means topology. Discrete topology. Then X is locally compact. Then X is locally compact. Locally compact. X is locally compact. Since for any since since for any since for any small x belongs to capital X, the sequence X is complex neighborhood of X. That sequence X is compact neighborhood of X. Neighborhood of X. Neighborhood of X. With with X bar equal to X. Sequence X bar equal to X. So using this concept will prove theorem. Prove get theorem. Prove theorem. Page number 138. Page number 138. Page number 138. Theorem for short answer questions. Theorem. This. Show that or prove that. Question formation is like that. Prove that or show that. Estimate, show that. Show that. Prove that or prove. A closed subspace of a locally compact space. A closed subspace of a locally compact space. Subspace of a closed subspace of a locally compact space is locally compact space. CPT means compact space. Compact space. Locally compact space is also a locally compact space. Is also a is also a is also locally compact. So locally compact. Locally compact. Is also locally compact. Proof. Proof. Let X be a locally compact space. Let X be a locally compact space. Let X be a locally compact space. Locally compact space. And Y be a closed subspace of X. And Y be a closed Y be a closed subspace of X. Subspace of X. Closed subspace of X. Now consider any small y belongs to capital Y and open set V. Consider any consider any small y belongs to capital Y. Small y belongs to capital Y. And an open set V and an open set V and open set V from Y containing Y from capital Y containing small y. Containing. Now Y belongs to capital Y and V is open in Y. Now small y belongs to capital Y. Capital Y. Small y belongs to Y. Open set in Y. Open set in Y. Open set in Y. Open set in Y. That implies small y belongs to capital Y. Small y belongs to capital Y. And V equal to Y intersection G. V equal to and V equal to Y intersection G. Y intersection G. Intersection. For some open set G in X, for some open set, open set, open set G in X. See, X is a local compact. That X is a local CPT means local compact. Local compact. That implies there exists an open set H. That implies there exists there exists right. There exists open set H. There is an open set H with H with H with containing Y belongs to H containing 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 Y belongs to H. Y belongs to H. On the closure H bar on the closure H bar closure H bar is compact. Consider is CPT means compact. Compact. Now consider K equal to H intersection Y. Consider K equal to H intersection Y. K equal to H intersection Y. Y is closed and H bar is compact. Y is closed. 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 And H bar is compact. And H bar is and H bar is compact. CPD means compact. H bar is compact. Consider K equal to H intersection Y. Consider H intersection Y. Consider K equal to H intersection Y. H intersection Y. Consider K equal to H intersection Y. So now Y is closed and H bar is compact. Now Y is closed. Y is closed. Y is closed. And Y is closed. Y is closed. And H bar is compact. And H bar is compact. H bar is compact. H bar is compact. That implies K bar is compact. K bar is CPT means compact. And Y in Y. And hence Y is locally compact. And hence Y is locally compact. Locally compact. Y is locally compact. This completes the proof, hence proof. So next theorem, also important for 10 marks. Two theorems. Theorem. Next theorem. Next theorem. Prove that or show that question format permission is like prove that or show that. Prove that or show. Let F be a mapping. F be a mapping locally compact space. F be a mapping of a locally compact space. Mapping means function. Mapping of a locally compact space. Locally compact space. Locally compact space. Maybe a locally compact space. X onto dot space HT means R dot space SP means R dot space Y R dot space Y if sorry this is okay afterwards R dot space page number 138 138 R dot space Y if F is continuous and open here and open continuous and open then Y is locally compact that is Y is locally compact then Y is locally so let X only let X be locally compact let X be a locally compact and Y be R dot space means R dot space yeah
ఫ్రూట్స్ ఏం చేయలే
సార్ సార్ మ్యూట్లో పెట్టమని చెప్పరా సార్ ఒకటి సార్
మొబైల్ డేటా కట్ అయిపోయింది మధ్యలో మళ్ళీ
సార్
చెప్పు
సార్ నేను నారాయణ మాట్లాడుతున్నా సార్ గుడ్ ఈవినింగ్ సార్ సార్ కొంచెం మ్యూట్లో పెట్టమని చెప్పరా సార్ ఎవరు మాట్లాడుతూ ఉన్నారు
మాట్లాడుతుందా
వాయిస్ ఎవరు పిల్లలు
అది నేను నా వైట్ బోర్డ్ ని నేను ఫుల్ స్క్రీన్ చేశా మీరు ఎవరు నాకు కనిపించారు
అవునా
వాళ్ళు
సార్
ఎవరు మరి నీకే తెలిసి ఉండదు చెప్పు మరి
సాగరిక అంట సార్
మెసేజ్ పెట్టండి ప్లీజ్ సాగరిక ప్లీజ్ మ్యూట్ ఆన్ ప్లీజ్ కీప్ ఇన్ మ్యూట్ అని పెట్టండి ఇంకా నేను ఫుల్ స్క్రీన్ నా స్క్రీన్ అంతా ఉంటది అసలు ఎవరు కనిపించారు మీరు నాకు సో continuous on to open mapping continuous on to open mapping continuous open mapping to show that Y is locally compact to show that Y is locally compact Y is locally compact consider any small y belongs to capital Y consider any small y belongs to capital Y. Now, F is onto. Now, F is onto. That implies there exists small x belongs to there exists small x belongs to capital X. Small x belongs to capital X such that f of x equal to y. F of x equal to y. How do we wrote f of x equal to y? By definition of onto function or bijection. What is the definition? The range should be equal to its codomain. That's why we wrote f of x equal to y is onto f of x equal to y. Let G be a neighbor of let G be NBD means neighborhood of y, neighborhood of y, neighborhood. Now f is continuous. Now f is continuous. F is continuous. Now f is continuous. Yet x that implies there exists a neighborhood W. There exists a NBD means neighborhood W. Neighborhood W of x in x of small x in capital X in x, such that f of W st means such that f of W f of W is subset are equal to G subset are equal to G subset are equal to. Again, X is locally compact. Again, X is locally compact. Locally compact. X is locally compact. That implies for this neighborhood. That implies for this neighborhood. NBD means neighborhood. W of x. W of x. There exists another neighborhood V. There exists another neighborhood V. Another neighborhood. V of neighborhood of x. V of x. Whose closure V. Whose closure V. Closure V. Closure V. Whose closure V is compact. 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 Whose V is compact. V is compact. V is compact. Such that string means such that V bar is subtract W. That implies f of V, f of V, f V subset are equal to f of V subset are equal to f of V bar. Bar. Subset are equal to f of W, f of W. Subset are equal to G. Subset are equal to G. Subset are equal to G. Finally, F is open. Finally, F is open. That implies f of V. That implies f of V. That implies f of V. That implies f of V is a neighborhood of Y. Is a neighborhood of Y. Neighborhood of Y. Neighborhood of Y. Also, we have f of V is also we have f of V. F of V is compact. Is compact. It is compact. Hence, hence
లీవ్ ఏంటి ఇక్కడ లీవ్ చేయాలంటే నిజం
compact. short marks answer question important.
ఎడ్జ్ ఇంట్లో ఏం కనిపిస్తాను పెట్టిన బ్రైట్నెస్ తగ్గించడం.
Theorem. Page number 138. 138. This is for 10 marks question. That is 18.8. Theorem. Question is prove that show that
సార్ హలో సార్ మేడం రియల్మీ ఎవరు మేడం? హలో మేడం కొంచెం మీరు మ్యూట్ లో పెట్టరా మేడం? మీరు బాగా మాట్లాడేది వాయిస్ బయటకు వస్తుంది. సార్ చెప్పేది మనకి ఏ క్వశ్చన్ ఏందని అర్థం కావట్లేదా? సార్ హలో
చెప్పండి.
సార్ ఇది పేజీ నెంబర్ 138 లోదేనా సార్ మీరు చెప్పేది?
130లో 18.3 మొబైల్ డేటా
18
కట్ అయిపోయింది, మళ్ళీ యాడ్ చేసి
సార్
18.18 18.3.8
ఇందాక 3.9 సార్ మీరు చెప్పింది?
3.9 అయిపోయింది, ఇప్పుడు 3.8
ఇంపార్టెంటా సార్?
3.7 నుండి 13.8 3.9కి వెళ్ళి మధ్యలో మిస్ అయింది, అది ఇప్పుడు చెప్తున్నా 18.3.8 హీరో. మొబైల్ డేటా మధ్యలో కట్ అయిపోయింది,
ప్లేన్ వైట్ బోర్డ్ అవ్వబడుతుంది సార్, ఏం అవ్వట్లేదు. అందుకోసం మీ వాయిస్ కూడా కట్ అవుతుంది, కనెక్షన్ ఎర్రర్ అనేది వస్తుంది మాకు ఇక్కడ.
ఒక్కోసారి కనపడితే ఒకసారి
రావట్లేదు సార్, అసలు లేదు సార్. లేదా జస్ట్ ఒక్క నేను ఓపెన్ చేసిన కానీ జస్ట్ ఒక 2 minutes లేదు సార్. నాకేం కనెక్షన్ ఎర్రర్.
theorem, if x and y are locally compact, అన్నాడు పేజ్ నంబర్ 138 తీసి 13.8. నా వాయిస్ అయితే వినబడుతుంది కదా, ఓకేనా? 18.8 if x and y are locally compact, వీక్ ఉంది, locally compact, then x cross y is also locally compact, then x cross y. is also statement. Proof. Proof. Let X and Y be locally compact space. Let X and Y be locally compact space. Locally compact space. Locally compact space. To show that X cross Y, we need to show that X cross Y, X cross Y. Consider any point. Consider any point. Consider any point. X comma Y. X comma Y belongs to X cross Y. Belongs to X cross Y. Let it equal to let G equal to let G equal to G suffix X. G suffix cross G suffix Y. G suffix Y. Be a basic neighborhood of basic NBD means basic neighborhood of X comma Y. X comma Y. In the product topology, the product topology, TP means topology. Hence, Gx and Gy are neighborhoods of, hence, Gx and Gy and Gy, G suffix Y, are neighborhoods of NBD. NBDS means neighborhoods of X comma Y. Neighborhoods of X comma Y. Respectively, RUSPLY, respectively, in capital X and Y. Capital X and Y. Capital X and Y. Capital X and Y. Now X and Y are locally compact. Now X and Y are locally compact. Locally compact. Locally compact. Locally compact. Locally compact. That implies there exists a neighborhoods. That implies there exists a neighborhoods. 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 There exists a neighborhoods. There exists a neighborhoods. Hx and hy. Hx and hy. Hx and hy. Hx and hy. Hx and of x comma y such that of x and y such that st means such that h bar is compact in x and h bar. The CPT means compact in x and h bar y is compact in y is compact in y is compact in y is compact in y. Hence we have hx and hy. Hence we have hx cross hy means product topology. Hx cross hy is neighborhood of x comma y in product topology means x cross y such that hx cross hy whole bar is compact in product topology x cross y since hx cross hy hx cross hy is subset or equal to whole bar is subset or equal to hx bar cross hy bar is compact CPT means compact. Hence product topology means x cross y is locally compact locally compact CPT means. This completes the proof. Hence proved. So one more point, zero number, page number 140. Page number 140. First we will discuss definition. Page number 140. 140. Definition. Let x be a locally. Let x be a locally. Let x be a locally compact Hausdorff space. Compact Hausdorff space. Hausdorff space. Hausdorff space. Hausdorff space X. X is called one point compactification of X. Is called 1 point is called 1 point compactification of X. 1 point compactification. 1 point compactification. One point compactification of X. What is the definition? Let X be a locally compact Hausdorff space X is called 1 point compactification. 1 point compactification. One short answer questions we discuss. Find the SAQ means short answer question. Short answer question. 18.4.3. Find the 1 point compactification. Find the 1 point compactification. 1 point compactification. Compactification. Find the 1 point compactification. 0, 1 means left open, right closed. 0.1 equipped with the usual topology on R. Equipped means fixing. Equipped with usual topology on R. USUAN. Usual topology. TP means topology. On set of real numbers on R means set of real numbers. Next, solution. So let I equal to I means interval, nothing but that is 0, 1. 0, 1. This is also closed interval 0, not left open. Right? Is the 1 point compactification of left open, right closed. Is the 1 point compactification. Is the 1 point. Fitting means point. Compactification. Compactification of J equal to 0, 1. Left open, right closed. Since by adding the point 0, by adding by adding the point 0, the point 0 to the interval j, the interval interval j, interval j. We obtain the closed unit. We obtain the closed unit, interval I, interval I, which is compact and Hausdorff, which is compact and Hausdorff's. Hausdorff's means Hausdorff space. Hausdorff F. Hausdorff's FF. Hausdorff space and contains J and contains J. Also, we observe that. Also, we observe that J is locally compact. J is locally compact. Hence, find the solution. This completes the solution. Find the solution. Next. Theorem. Next theorem. Yr-Msc. 18.4. Page number 140. Page number 140. Theorem. Let X be a locally compact. Is prove that question formation is like that. Prove that. Show that X be locally compact. X be locally compact. X be locally compact. Hausdorff space. HD means Hausdorff space. S means space. Let C be a compact subspace of X. Let C be compact subspace of X. Subspace of X. Compact subspace of X. Subspace of X. And let G be the neighborhood of C. Let G be the NBD means neighborhood of C. Which does not equal the full space. Which does not equal the full space. Equal the full space. full space, which does not equal the full space. Then there exists a continuous real function on X. Then there exists a continuous real function on X. Real function on X. All of those values lie in the all of those values lie in the closed interval 0, 1. Lie in the closed interval 0, 1. Such that f of c equal to 1. Such that f of c equal to 1. And f of g dash equal to 1. And f of g dash equal to f of g dash equal to f of g dash equal to 1. So proof let X be a locally compact Hausdorff space. Let X be a locally compact Hausdorff space. X be a locally compact Hausdorff space. H space means Hausdorff space. And X and X and X and X. B its one-point compactification. B its one-point compactification. PT means point. Compactification. COMPACT. Actification. One-point compactification. One-point compactification. Let C be a compact subspace of X. Let C be a compact subspace of X. Compact subspace of compact subspace of X. Compact subspace of X. Yeah. Okay. And G be a neighborhood of C. And G be a neighborhood. G be a neighborhood of C. And G is not equal to X. G is not equal to X. That is, G is open and C subset are equal to G. And G is open open. C is subset or equal to C is subset or equal to G. G. Now C is now C is subset or equal to G is subset or equal to is subset that implies C subset that implies C subset that implies C intersection G dash C intersection G dash C intersection G dash that equal to null set. Null set. Hence C and G dash are hence C and G dash are distinct means disjoint closed subset. That means disjoint closed disjoint closed subset of X. Subset of X. Subset of X. Subset of X. So hence by Euredan's lemma, Euredan's lemma, Euredan's lemma, there exists a continuous function. There exists a CTS, continuous function. There exists a continuous function. G X to R, G X to R, X to R, all of whose values all of whose values I will come within few minutes.
సార్
whose values page number 138, page number 140, 18.4.4, all whose values lie in the closed interval whose values lie in the values are lies in the closed interval 0, 1, such that g of c equal to such that g of c equal to 1, g of c equal to 1, and g dash of c equal to g dash of c equal to g dash of c equal to 0. Now let f be a restriction. Now f be a restriction on g dash. Then we have the value of g, then we have the value of g, value of g lie in the unit interval, lie in the unit interval unit interval unit interval 0, 1, 0, 1, and f dash c and f dash c equal to 1 and f g dash equal to and f g dash g dash equal to 0, g dash equal to 0. This completes the proof, hence proved. Hence proved. Okay, today we discussed 4 theorems, two definitions. In these 4, one is compulsory answer.
సార్ వాయిస్ బ్రేక్
Okay.
అవుతుంది సార్
In-
ఉమా సార్ వాయిస్ బ్రేక్ అవుతుంది సార్ మీరు మాట్లాడేది
మరి మొబైల్ ఫోన్ అన్నా మరి ఓకే లైవ్
సార్ సార్
చెప్పు
సార్ కొంచెం మీ నెంబర్ చెప్తారా సార్?
నాదా రాసుకోండి 94909
ఒక్క నిమిషం సార్. 94
909 26009
2600
009.
9.
Okay. You
ఓకే సార్.
topology,
ఓకే సార్. 94.
what we discussed, those are all important and the exam point of view only we discussed it in the 8 classes, right?
ఓకే సార్. అయితే సార్ దీంట్లో మెయిన్ ఎక్కువగా ఏ చాప్టర్స్ ప్రిపేర్ అయి ఉంటే అంటే మాక్సిమం
అదే
అంటే
మనం ఏదైతే
అంటే
డిస్కస్ చేసామో ఈ 10 యూనిట్స్ లో అది ఓన్లీ ఎగ్జామ్ పాయింట్ ఆఫ్ వ్యూ, షార్ట్ ఆన్సర్ అండ్ లాంగ్ ఆన్సర్. You have to practice definition first, next theorem, right? Total
ఓకే
topology is
సార్.
like that. Topology and real analysis almost same. Definitions, theorems.
ఓకే
Okay.
సార్.
I'm leaving. Thank you very much, all of you. Wish you best of
ఓకే
luck.
సార్. ఓకే సార్. థ్యాంక్ యూ సార్. థ్యాంక్ యూ.